Okay, batch, here we go. We're going to have a look at section 4K, which is volume of prisms. So again, hopefully this stuff is pretty intuitive because it is a revision of what we've learnt previously. Okay, so the first part we want to look at is our different units for measuring volume. The difference here is we've got two sets of volume units that we can use for what we say volume and capacity. So our first one, we're looking at our units of kilometers cubed, meters cubed, centimeters cubed, and millimeters cubed. Now you've got this conversion flow chart in your notes, okay? And we simply times by that conversion factor of 1,000 cubed, because now we're in volume, not area, okay? So we've got to go from kilometers to meters, it's times by 1,000 cubed. Meters cubed to centimeters cubed is times by 100 cubed. And centimeters cubed to millimeters cubed is times by 10 cubed. Conversely, if we go back the other way, so if we go millimeters cubed to centimeters cubed, we're going to divide by 10 cubed, centimeters cubed to meters cubed, divide by 100 cubed, and so on. Okay, so you've got that, and we're going to use that shortly. Alternatively though, we also have our units of megaliters, kiloliters, liters, and milliliters. Okay, now these are much nicer because all of them we just times by 1,000, times by 1,000, times by 1,000, or similarly divide by 1,000 to go through those ones. Now there is a link between these units, okay, and our two sort of endpoints are over here. That 1 cubic centimeter is equal to 1 milliliter, okay, and that 1 cubic meter is equal to 1,000 liters. So these are nice endpoints if we've got to convert say between centimeters cubed and liters, for example. Okay, so we go centimeters cubed, well that directly correlates with milliliter cubes, just milliliters, and then we could do our conversion. Okay, so our first example, now these are in your notes, so make sure you're copying along with these ones. Okay, so we're converting meters cubed into centimeters cubed. Okay, so we're just following along here. So we're going to need to times that by 100 cubed. Okay, we're going to do this on a calculator. We don't need to be able to do this by hand. Okay, and we simply get 24,000 centimeters cubed. Okay, so it's just following our flow chart through. Similarly, in our second one, okay, again, this is in your notes. Okay, we have 12,500 milliliters, and we need to convert that to kiloliters. Okay, so if I look here, I'm staying at milliliters, I'll go out to kiloliters, so I'm going to divide by 1,000 and divide by 1,000 again, or combining those is dividing by 1 million. Okay, and so when we do that, we're going to get 0.0125 kiloliters. Okay, so it's just utilizing this flow chart to work our way through converting between those units. Okay, so next up, okay, we've really got our main crux of it here, which is how do we find volumes of prisms? Okay, now our basic idea is what I've got written at the top here. Our basic idea of how to find the volume is you find the area of the end and times it by the length. Okay, so when we mean the end, okay, we're talking about the end that if you cut through the prism and open it up, you get the same shape. So for example, okay, I could cut through this prism anywhere here, okay, and I'm going to get the same cross section. Okay, so it's not going to change. For our cylinder here, I can't cut vertically. I've got to cut through the middle here. Okay, so we're going to say our circle at the end. Okay, that's the area of the end that we're looking at. Okay, so let's start with this one here. Okay, so if we do take this as the area of the end, okay, then my volume is going to be 2 times 4 for the area of the end, okay, times by 3 for the length. Okay, 2 4s are 8 times 3 will give us 24. Okay, so it'll be 24. Now, we can't just say 24 what? Don't forget our units. So in this case, it's meters, and because we're volume, it is cubed. Okay. Similarly, okay, for our cylinder here, okay, I've got a circle at the end, remembering that our area of a circle is our pi r squared, okay, times by our length of our cylinder here, which is going to give me pi times our radius of 2, so 2 squared times our length of 6, okay, which is going to give us 24 pi. Right, and when we pop that in our into our calculator, we're going to have it spit out as 75.40 to 2 decimal places centimeters cubed. Okay, so you need to think though, we could have any shapes asked to us. Okay, so we could have a triangle prism like this. Okay, so you have to find our area of the end here using our triangle formula, times it by the length. Okay, and in fact we can have any sort of wonky shape. Okay, for our prism. Okay, and we use this area, which they would give you to you if it was something crazy there. So take that area and multiply it by that length. Okay, so you'll need to look back at your notes at times for your area formulas. Okay, pick the right one, find that area at the end, and it's one last step, times it by the length. Okay, there's nothing too crazy here. And in fact, this section gets us straight into looking at composite shapes as well, like we've got here. Now, don't get confused with surface area. We don't need to worry here about shared faces or that being a problem. We just simply have a rectangular prism down the bottom and a cylinder on top. Okay, so in this case, we're going to add them together. Okay, so we're going to go for our volume equals our length times our width for the face of our prism. Okay, and I'm going to use height just for this length here. But really, it's the area at the end times by that length, plus I've got my pi r squared times by my height for my cylinder. Okay, so for my prism at the bottom, okay, I am 6 times 2 times 6. Okay, because I've got 6 by 2 this way, and then this length is 6 as well, because we've got our double dashes indicating they're the same size, plus pi times our radius. Now we need to think here. What's our radius going to be? Well, since our cylinder, okay, sits neatly on top of our prism at the bottom, we know that the diameter of the circle is going to be the same as this dimension here. So our diameter of our circle is 6, therefore our radius is going to be 3. So 3 squared times by our height, which is 2. Okay, so we're going to get here overall, and I'm just going to cheat here and have a look at what our answers are in the textbook so I don't have to worry too much. Okay, now they do want milliliters, but when we work this out we get 128.55 centimeters cubed. Okay, but remembering we have that conversion, which is 1 centimeter cubed equals 1 milliliter. So in fact, our answer doesn't change. It's still 128.55 milliliters. Okay. So there's all sorts of shapes that we could use for this though. So don't forget they could do something a little bit different, because we've got here, say a rectangular prism. But instead of adding to it, okay, we could have a hole cut into it that's a square at the top or something like that. Okay, so we could have this sort of situation going on where they're actually cutting a section out. Okay, still the same idea, it's just this time you'd be finding your volume of your large rectangular prism and taking away the volume of this smaller prism inside. Okay, so they're not always just additive type of questions. You can need to subtract some values off there as well. Okay, so that's the worked examples covered. Okay, hopefully you got those down in your notes and that you're ready to go to hit some of the questions for this section. All right, good luck.